Welcome you all students. I come up with a question from the screw jack. The pitch of a single threaded screw jack is 10 mm and its mean diameter is 60 mm. If the coefficient of friction is 0.08, determine the force record at the end of the lever 500 mm long measured for axis of the screw tooth. First one, raise a 10 kilonewton and lower the same load 10 kilonewton. So here given screw jack 10 mm pitch of this single threaded screw jack, which is small p 10 mm, and then mean diameter is given small d 60 mm. So if you want to calculate the radius, then which is equal to 30 mm, d divided by 2. Then coefficient of friction is given, which is mu 0.08. Determine the force record at the end of the lever length, which is given 500 mm. Okay, to find the effort required to rise, so P1 we need to find, and lower the same load, so Q1 we need to find it out. So here the weight is given, weight of the load on the screw head, which is 10 kilonewton. Okay, solution, I just going to find out the first on effort record to lift the load. Okay, so P1, which is equal to, we are well familiar with the formula, W into R divided by capital L into tan inverse of alpha plus pi. Okay, that's all. So W is the value 10 kilonewton into radius is 30 divided by length, which is 500, and then tan inverse of tan of alpha and pi we needed, that we need to calculate it. So just calculate the alpha value first. How will you calculate the alpha value? So we have direct formula. Alpha is nothing but it's a helix angle or a screw angle. Okay, so tan inverse of pitch P divided by pi d. So here if I put it, tan inverse of 10 divided by pi into 60, I'll get 3.03 degree alpha. Okay, so I got the alpha value. Now it's time to, it's a screw angle or helix angle. Okay, then pi needs to find. Pi is nothing but friction angle, which is tan inverse of mu. So here I will get 0.08 tan inverse. It will give 4.57 degree. Okay, which is a pi. Now if I substitute, P1 will be 10 into 30 divided by 500 into tan alpha is 3.03 plus 4.57 degree. Okay, so I will get a value for P1 in terms of kilonewton. So here 0.08 kilonewton required to lift it. The second one, Q1, which is effort required to lower. So we know the formula, just W into R L tan of alpha minus pi, it's the difference, So here just to substitute, we may get 10 into 30 divided by 500, okay, uh, which is equal to tan of 3.03 minus 4.57. Okay, so here we will get anyhow lesser value when compared to the first one. It's a lowering force, so 0.016 kilo Newton. Okay, so this is the Q1, effort required to lower the load. This is the effort required to rise up the load. Okay, so I hope you understood. Thank you so much.